Hello everybody, we're Team Random Access Misery, and in this video we're going to tell you about our DSD project. Okay, the DSD project is about a smart greenhouse which would regulate the amount of water and the amount of light reaching the greenhouse based on the inputs which indicate the amount of moisture in the soil and the amount of light reaching the greenhouse. Okay, we do this through two input sensors. The first one is the soil moisture sensor, and the soil moisture sensor basically tells you how dry the soil is, which means that as the number grows smaller, the need for irrigating the soil would increase. This is done through passing an electrical pulse between the two poles of the moisture sensor, and based on the resistance it would determine whether or not this soil needs irrigating. The other thing is that we have an LDR, or a light dependent resistor. The resistance of the LDR would decrease as the amount of light intensity increases. So we connected it in series with another resistor, and the voltage on this resistor would increase as the light intensity would increase. And we connected those to the Altera board as follows. The soil moisture sensor was connected to the VCC and the ground coming from the Altera board. It has an output which was connected also to the Altera board. We not directly, of course, and we also connected the output from the LDR circuit to the Altera board, but not directly. My friend Omar would introduce you to how we connected these outputs to the Altera board.
Okay, you now have two inputs. One is from the soil moisture sensor and the other one is from the LDR circuit. These inputs are analog, so we need to convert them to digital sensors in able to be able to use them in the Altera board. So we use for that an analog to digital converter. It has 8 input pins, but we only used one of them. It depends on a multiplexer built in it. So this multiplexer needs 3 pins. We connected them to the ground in order to select the first input, which is the only input we connected. This ADC produces 8 output pins, which give us a range of output between 0 and 255. So we connected them to the Altera board. This ADC also uses a clock. This clock is produced by the Altera board. It has also 2 pins. These pins are the startup conversion and end of conversion. We connected them together in order to restart the conversion of the input signal after each conversion.
We will be talking about the software part. First of all, as Omar said, the ADC requires a clock whose frequency is 500 kHz. However, the FPGA outputs a clock whose frequency is 50 MHz. We generated a clock whose frequency is 500 kHz, and we outputted it on a pin which is connected to the ADC. The ADC outputs 8 bits. So we connected them to 8 pins on the FPGA, and we show those values on the PC on the 7-segment displays on the FPGA. And Ibrahim will be talking about what we will do, depending on those values.
Okay, so we have 2 modules, one to control the water pump and another one to control the lamps. We receive 256 levels from the ADC. So for the water pump, we divide those levels into 3 ranges. The highest range, the water pump starts working. This range means that the soil needs water. For the lowest range, the water pump stops working, and for the range in between, the water pump doesn't change its state. We made it this way because we wanted to stop the water pump from oscillating between the 2 states. For the module controlling the lamps, we have 4 ranges, and for each range, the number of lamps turned on is increased by 1. This is based on the reading we get from the LDR, and that's it.
Okay, and now we will talk about the outputs of our project. The first output is the water system. As we said, we use a water pump and the water source in order to irrigate our plant. We receive a signal from the board in order to turn on or off the water pump. If the value of the sensor, of the soil moisture sensor, is greater than 150, the pump start working and start delivering water into the plant. If the value was between 100 and 150, the state remains the same. If the pump is on, it remains on, and vice versa. If the value was under 100, the pump will stop, and because we know now that the plant is totally watered and it doesn't need any more water, we control the on and off states of the pump using a relay. If the value to the relay was 1, then therefore it connects the pump to the switch, and the water starts moving.
Now I'm going to talk about the light system in our project. So the FPGA reads an input from the light sensor, and depending on the value of this reading, it turns on one or more lamps here. So if the value is less than 40, it turns on 3 lamps, and if it's between 40 and 120, it turns on 2 lamps, and if it's between 120 and 180, it turns on 1 lamp, and if it's above 180, it does not turn any lamps, because we know that this soil has enough light. So to turn on these lamps, we need 220 volts, but the FPGA only provides us with 5 volts, so we have used a relay. This relay receives a signal which is 1 or 0 from the FPGA, and if the signal is 1, it connects the lamp with the voltage source, which is 120 volt, and if it's 0, it does not connect them, so the lamp will not turn on. And we have also used this cylinder to isolate the LDR, which is here, from these 3 lamps, so that its reading is not affected by the light from these 3 lamps. And now let's try out our project. As you can see here, this 7 segment here displays a value which is read by the LDR sensor, and it ranges from 0 to 255. Now its reading, as you can see, it's fluctuating between 127 and 126, and this value is between the range which is 120 and 180, so only one lamp is turned on. But now if we have turned off the light, you will see the difference. The 3 lamps are turned on now, and if we have the value here on the BCD, it's 37, and this means that it's below the range, which is 40, so 3 lamps are turned on. And if we try to increase the light which the sensor is exposed to, as we can see here, the flashlight, as it's approaching, now the value increased and it's now 67, so only 2 lamps are turned on. And if we keep moving it towards the lamp, it's now 156, and only 1 lamp is turned on, and now the LDR reads a value which is 135, and this means that no lamp is turned on.
Now let's see our other output, which is the watering system. As we see, the value of the soil moisture sensor is now 198 and 199, so the pump should be working, but we should connect the electricity. So now if we connect the electricity, the pump will work. As you see, the value of the soil moisture sensor is now below 100, so the pump has stopped. And the irrigation system has stopped because the plant is now, it doesn't need any water. And now we are done, and our plant has enough water and enough light, and it can grow under any conditions. Thank you for watching our project. We hope you enjoyed this video.